This is practice A for section 6.3. We're going to use the diagram to complete this statement. So here's our diagram. In our diagram we have two triangles that are different sizes. This one's definitely bigger than this one, but we have two pairs of congruent angles. That means that these two triangles are similar. So these third pair of angles need to be congruent as well, and then these corresponding sides are proportional, meaning that this ratio y to 8 is the same thing as x to 10. And that's the same thing as 16 to 12. So in number 1, we're going to write a similarity statement. Triangle MON is similar to triangle GHI. All you're doing is lining up M with what it goes with. Line up O with what it goes with. N goes with I. Same thing here. This is a statement of proportionality. Segment MN corresponds with segment GI. So this ratio equals this ratio, O to N compared with H to I, M to O compared with G to H. Number 3, we're writing a proportion, 16 to 12. These are corresponding side lengths. That must be the same thing as x to 10. 16 to 12 equals x to 10. Number 4, 12 to 16 equals 8 to y. 12 to 16 equals 8 to y. There's a corresponding sides. So when you write two ratios of corresponding sides, they're definitely equal to each other. Okay, now you need to solve this proportion and solve this proportion. I already have the answers written there. Kind of show you how you type it in the calculator. So what we're going to do here is we're going to take 16 times 10 and then divide by 12. And that gives you 13.33 forever, which is the same thing as 13 1/3. We'll solve this one now. We'll do 8 times 16 and divide by 12. And that gives you 10.6 forever. There's a 7 on here because obviously the 6 would round up to a 7. 0.6 forever is 2/3. So this is 10 2/3. Which triangles are similar to triangle EFG? Explain. Well, here's a triangle. We know a 90-degree angle and a 60-degree angle. That means the other angle is 30. So if you solve for the other angles in all of these, you can see which triangles have the same angle measures. So obviously, if you have the same angle measures, you're going to be similar by angle, because if two pairs of angles match, the third pairs definitely match. This guy doesn't work because a 35 and a 55 doesn't match your 30 and your 60s. Determine whether triangle ABC and triangle DEF are similar, not similar, or cannot be determined from the information given in the figure. So here's how this goes. They're definitely similar if they have two pairs of angles in common. They're definitely not similar if they don't have two pairs of angles in common. You can't tell maybe if there's not enough information. So for example, you know these two angles. You can solve to find this one. Now, if you know this angle is 31 degrees, this triangle over here has a 41-degree angle, and it does not match either of these angles here. That's why this is definitely no. So you need two pairs of angles to match. Third angles theorem tells you you actually need those third pairs of angles match as well. And we don't have that. But you do over here. If you solve for these angle measures that are missing, you notice that all the angle measures are the same. So these are definitely similar triangles. Now, this number 11, maybe we'll do this one as well. We're going to figure out the missing measure of this triangle. So let's figure out what angle C is. We'll do 180, and we'll subtract 70, and we'll subtract 67. And you're going to end up with 43. And that's kind of what I thought you were going to end up with, because notice how this angle matches this one. Now there's no way for us to know what these other angles are, so these could be similar. But you can't prove it. Number 12, they give you no measures, but they give you congruent angles here, which means the triangle is isosceles, so you know those sides are the same. And the vertex angle is 90. So what that means is if your vertex angle is 90, then your base angles are the same. You split the other 90 degrees. This triangle here, it's a smaller triangle, but it's also isosceles because these two sides are congruent. So that means that these two angles are the same as well. And notice how I have them marked differently than those ones because originally I didn't know that they were 45 as well. But if your vertex angle is 90, then your base angles are 45 as well. So if you have all of the same angle measures in two pairs of triangles, then they're definitely similar by angle-angle. They're both right isosceles triangles.